This lesson is for Unit 1, Section 1, Matrix Operations, and this is the Day 3 lesson. So we're going to talk today about the determinant first. It is a real number associated with a square matrix, right? So that's only a 2 by 2 or 3 by 3 or so on. It's either written as DET and then the name of the matrix, or the name of the matrix inside what looks like absolute value bars. So to find the determinant of a 2 by 2 matrix, what we're going to do is we're going to take the downward diagonal left to right. We're going to find that product, so A times D, and then we're going to subtract the product C times B. So left to right, down minus up. So on our first one here, right, this is the down one, so 7 times 3 minus the up one, 2 times 2. So this is going to be 21 minus 4, which means the determinant of A, and I'll even write that, determinant A is 17. All right, that's the value of that. And we're going to really learn why we need to know the determinant later once we get to the inverse. So you're going to go ahead and try this one. You can pause and I will show the answer. All right, so the determinant of this one is -1. To find the determinant of a 3 by 3 matrix by hand, we're going to do the following. We're going to take the two columns, the first two columns here, and we're going to rewrite them to the right of it. So notice here I had ADG, I added ADG. BEH, I added BEH. We're going to take the product of each of the downward diagonals and add those up. Right? We're going to find the sum of the downward diagonals. Then we're going to find the sum of the upward diagonals, and then we're going to take downward minus upward. All right? So here, I'm going to take this column, put it over here. I'm going to take the second column, also put it there. So now I'm going to find each of the downward diagonals. So that's this one here. So we're going to do 4 times -7 times 2. Plus the next downward diagonal. So that's 3 times 0 times 1. And then the last downward diagonal, plus 1 times 5 times -2. So for our downward diagonals, we have -56 plus 0 plus -10. So I'm just going to write -10. Equals -66. All right, now we're going to do the upward diagonals. So start in the bottom corner. It's our first upward diagonal. 1 times -7 times 1 plus -2 times 0 times 4 plus 2 times 5 times 3. So that's going to be -7 plus 0 plus 30. So that's 23. So now I'm going to do downward minus upward. So that's -66 minus 23. So the determinant here is negative 89. There's another way we could do this, right? This is quite a bit of work. So we could do this using the graphing calculator. All right, so this is why you need to download an emulator or have a graphing calculator. To find the determinant of a 3 by 3 matrix with a calculator, we're going to do this. All right, and I have the steps listed here. I'm going to show you on an actual calculator as well. So we're going to hit second and then the x to the negative 1 button, right? That's right here. That's where matrix is. We'll go over to edit. We'll select which matrix we want to use. We may as well just use letter A. We're going to adjust the size to make it a 3 by 3, and then we're going to type in all the entries. And then we're going to quit the screen by hitting second mode, right? See how it says quit up there? Then we're going to go back into the matrix button and go over to math, select determinant. Then we have to go back into matrix to select which letter and hit enter. So I'm going to show you this on the calculator, right? This is what your calculator should look like. Normally your screen would be up here. So that's fine. All right, so we're going to go into matrix. We're going to go over to edit. So over, enter. We want a 3 by 3 matrix. And now we're going to put in the values, and that's actually our next example, right? We're going to be trying this one, which is the same one we just did, just to see that we get the same answer. So we're going to put these in. 4, 3, 1, 5. Now this is negative 7. We can't just use the minus sign. We actually have to use the negative symbol. It'll give us an error if we try to use the minus sign. 0 is fine for that one. 1, negative 2, and 2. So now this is our matrix A. So we're going to quit, second, quit. So now I'm going to go back into the matrix options. I'm going to go over to math and see how it says determinant. I'm going to hit enter. And now it's waiting for which matrix to do. So we're going to hit second matrix. And under names, we want that one. So I'm just going to hit enter so it enters it. And enter again. And look at that. We got the same exact answer we just had for the last one, finding the determinant. The inverse is what you would multiply a matrix by to get the identity matrix. So if you think of it this way, it's almost like the reciprocal, right? If I wanted a number and I wanted to know what I would have to multiply that number by to get to 1, I would take the reciprocal of it. The inverse is a matrix's reciprocal, basically. So to find the inverse of a 2 by 2 matrix, we're going to find the determinant first. We're going to have 1 over the determinant, and then what's going to happen is these, the downward numbers, switch places. So this was A up here, D down here. Now it's D up here, A down here. And the other two, the upward ones, are going to change signs. All right? If it was positive, it becomes negative. If it's negative, it becomes positive. So flip downward, change upward. And what this also means is because you can never have 0 in the denominator of fraction, if the determinant of a matrix is 0, then it has no inverse. Right? You cannot have an inverse of a matrix if its determinant is 0. So we're going to find the inverse here. So we'll start by finding the determinant. Downward, 3 times 4 is 12, minus upward, 5 times 2 is 10. So the determinant is 2. So to find the inverse, it's going to be 1 over 2 times, remember, switch places. So this is now 4 up here. This is now 3 down here. Change signs. So the 5 is now a negative 5. The 2 is now a negative 2. Some things will let you keep it like this. Generally speaking, I will distribute the scalar. So I'm going to distribute 1/2 to everything in here. So half of 4 is 2. Half of negative 2 is negative 1. Half of negative 5 is negative 5 halves. I could also write negative 2.5 there if I want. Half of 3 is 3 halves, or I could write 1.5. And that right there is the inverse of A, right? This is A negative 1. All right? So let's do another one, right? Because these are, I want to make sure we know how to do these. So down 6 times negative 2 is negative 12, minus up 1 times negative 8 is negative 8. So negative 12 basically plus 8 is negative 4. So this is going to be 1 over negative 4. Switch places, negative 2 up top, 6 now down below. Switch signs, this is now a positive 8 and a negative 1. And now we're going to distribute that negative 1/4. So negative 1/4 times negative 2 is positive 1/2. Negative 1/4 times negative 1 is positive 1/4. Negative 1/4 times 8 is negative 2. Negative 1/4 times 6 is negative 3/2. Again, I could put 0.5, 0.25, and negative 1.5 there if I really wanted to. So you try this one, you can pause, and I'm going to show the answer. All right, so that is our inverse of A. To find the inverse of a 3 by 3 matrix, we're only going to do it with a graphing calculator. So again, we're going to do the same steps we did to enter the matrix. We're going to go to second x to the negative 1, which is matrix. We're going to edit whichever matrix we want to do, change the size if we need to, type in the entries. And then all we have to do is select the letter of the matrix and raise it to the negative 1 power. So we're going to do that for this matrix right here. All right, so I'm going to go into my graphing calculator, clear all that out. So I'm going to go into the matrix screen. I'm going to edit that same 3 by 3 one I had before. So now my entries, we have 1, 2, negative 1, 2, negative 1, 3, negative 1, 0, 1. All right, so I'm going to quit this. I'm going to select the matrix. So that's matrix A. And I'm going to use the actual button that I was using for matrix to show that it's to the negative 1 and hit enter. And that right there is my inverse of that matrix. Right? And that's all we need to do. It's done for us. There's nothing else to do. So we can go here and just write our answer. So that was 0.1, 0.2, negative 0.5, 0.5, 0, 0.5, 0.1, 0.2, and 0.5. All right, and that's it.